This lesson, we'll learn the basic of parallel LCD, specifically the Hitachi LCD. So what is that? LCD stands for the liquid crystal display. I think most of you already know this. But what is the Hitachi? Hitachi is a Japanese company that invented this LCD. So Hitachi is the brand. Why do we use this in our classroom design? It's cost effective, which means it's inexpensive, cheap, usually around $3 to $5. I don't know the price after 10 years, but the price should be similar. When you buy it, you may see another electronic device that comes with this LCD. That is the I2C LCD1602 chip. Using this chip, you can control the LCD easily. It has ground and a VCC pin. A pin connects to the data and also a clock signal pin. To use the chip, you need to know I2C. Without this chip, you need to connect more wires from your microcontroller to the LCD in order to make it work. So this is the trade-off. If you use Arduino, you can simply call the Arduino library to control LCD, and it's very easy. Fortunately or unfortunately for our class, we don't use Arduino, so we use it in the hard way. This page shows what kind of thing we can display on LCD. The chart on the right hand side shows this letter, symbol, and the numbers. We can use this LCD to display letters, numbers, and some other symbols like heart. Arrows. What is this? We can use this LCD for our class to learn embedded system, to learn Japanese such as katakana, hiragana, and kanji. Since LCD can show Greek letters, we can reveal Greek. So we're gonna hit more than one bird with one stone. Now let me show you how to wire this LCD. If you orientate the LCD this way, the pin on the top left corner is the VSS. This pin connects to ground. The pin next to that pin is VDD. Connect this pin to VCC. That is 5 volt. Do not use 3.3 volt. These two pins power up this LCD. The third pin is V0. It is a pin that controls the contrast, which means how dim or how bright of the screen is. Connect this pin to a potentiometer. You can use 1 kilo ohm, 2 kilo ohm, 5 kilo ohm, 10 kilo ohm potentiometer. They all work. The only difference is how much you need to spin the knob of the potentiometer to get a contrast. The fourth pin is V0. It is the register select pin. This LCD has two modes, command mode and the data or information mode. If the LCD is in command mode, you are about to control this LCD. Commands like moving the cursor to the left or to the right, clear the screen, or so on. For the data or information mode means it accepts data. The data such as the letters, the numbers, the special characters that will be displayed on this LCD. Next pin is the read or write pin, the RW pin. If a logic 0 is sent to this pin, we are about to write the data into this LCD. If we send a 1 into this pin, that means we read the information from this LCD. Since we use the software driver to control LCD, don't worry about these two pins for now. Next pin is the most unique pin. It is called the enable pin. This pin receives clock signal. The LCD responds to the falling edge of this clock signal. Once the LCD detects the falling edge, based on all pins configuration, LCD executes. So the cursor can move, screen can be cleared, or symbols will be displayed on the LCD. It is like using the Windows command prompt or Ubuntu's terminal. After entering the command, hit the enter key to execute the command. The next 8 pins are D0 through D7. They are the data pins. Each pin takes 0 or 1. 8 of them is a 8-bit binary value that represent the letter, number or symbol going to be displayed on the LCD. In order to know what's the 8-bit value of a character, we need to use a chart, and this chart is available in the LCD datasheet. Here is the chart. It is a long chart, so I split them in half. This side is the upper portion, and the other side is the lower portion. The side shows the lower nibble, the lower 4 bits of the data. The top header shows the upper 4 bits of the data. For example, if I want to display the letter A, the uppercase letter A on LCD, find this chart in the datasheet, locate A, the lower nibble is 0001, and the upper nibble is 0100. Together is 01000001. These 8 binary bits are sent into the LCD's 8 data pins. Send the clock trigger to execute. A will be displayed on the LCD. Let's have another example. This time I want to display my name, Mo. First, locate the uppercase M on the datasheet. The data is 01001101. Send these 8 bits to the 8 data pins, and then send a clock signal or press the push button to generate a clock signal to enable it. M will be displayed. Then locate the uppercase letter O. The data is 01001111. Send a clock signal or press the button to generate a clock signal to execute, so O will be displayed on the screen. I built a circuit to show you how this works. And the enable pin of the LCD connect to the push button in this circuit. If you design using microcontroller, there is no push button needed. First, I turn on the power, and then I switch to the read mode. The 8 switches on the lower portion connect to the 8 data pins. Remember, the letter M is 01001101. If you look at the handle of the switch, if the handle is lifted, that means it is a 1. Otherwise, it is a 0. If you look at the 8 switches, it is 01001101. After the data are set, I press the push button to execute it. This push button generates a clock signal. This signal entering to the enable pin of the LCD. The number M displayed on the screen. Now let me do the same thing but to display O. For uppercase O, the data is 01001111. Click the push button to generate a clock signal. The uppercase O is then displayed on the LCD. Please note, for a letter, its uppercase and lowercase have different binary values. The last 2 pins are the power and the ground to turn on the backlight. If I make a design, I always use them, otherwise the LCD is very dim. This page summarizes the pin connections. It shows how to connect the LCD pins to the pins on the TM4C microcontroller. We need these 5 files for this LCD lab. The first 2 files are new, and they contain the core code. You need to modify so the program can meet the new design requirements. Last 3 files are the files that we are already familiar with. These are the key functions for LCD lab. The first one is LCD clear function. This function clears the screen and moves the cursor to the beginning of the LCD. LCD out string displays the string, the text. LCD UDEC function used to display decimal numbers. LCD output char display the characters. LCD out UHEX display the unsigned number, but this number is in hex format. Since the baseline code is provided, you need to do a simple code analysis to see how to use these functions. Not too hard, very easy. then use them to write the code. Let's analyze this code. In the main function, first line, declare an unsigned 32-bit integer. Initialize the phase lock loop. Initialize the LCD, so this function has been defined. We don't need to worry about anything of it. Initialize the n to be 0. Clear LCD first. Display system starts message first. Wait 1 second. Then run the infinite loop. Every loop, clear LCD and display the current nth value. Wait 1 second. Increment by 1 and then begin another loop. And then do the same thing over and over again.